formula about arc length.
So the next test we're taking goes all the way, it's all chapter 8 to now.
To 7.4.
Okay.
Part of 7.4. Okay, so we need that.
Long ass.
No, this is a little lowercase s. There is a big S, that's for surface area. That's also in section 7.4, but this is the only one I'm going to talk about today. Arc length. And it's because they're very easy to do with just a few little rules behind it. There's a nice development of this if you have time. Read through this. It talks about your old distance formula. Remember doing the distance between 2 points, the square root of x2 minus x1 squared plus y2 minus y1 squared, all under a square root. And then you divide through by dx. This will be actually a dx when you do it with the setup, and this will be a dy, and you divide through by dx, and that turns dy over dx into the first derivative. So it's really very cute. And this is a dx squared over dx squared, and that's just a 1. So the rules are so nice. You're going to find the first derivative. Find the first derivative. You're going to square it. You're going to add it to 1. And then you're going to f-end the square root of that piece that you've just done. So I'm going to draw a little arrow under here. It only works for what are called smooth curves, and they can't double back on themselves. So the curve, it can be anything like this, but it can't be like this. You know the little ribbons that you see that they put on people for various causes and such? It can't be that where it crosses back on itself. So it can't be like this. But other nice smooth curves, they do have to be differentiable. And it's all there in your book. You can take a look at it. But I guarantee you, all the ones in the homework and on the test, they all are appropriate for this. So look how nice to do this. Suppose the problem says find the arc length. For f of x, even easier than that, for
Why did you put the X in the bottom?
Yeah, because you put one to the side and then one to the bottom.
because the one to the
Oh,
side
it's negative one.
it is really up on the top,
Yeah.
and this one I really need down on the bottom.
Put 2x to negative 1.
Yeah, if I brought it up, it would go up as x to the
1/2
negative 1.
x.
1/2 x to the negative 1. Rather I write it 1/2 x to the negative 1?
No, that's fine.
Oh, okay.
Regardless.
Okay.
Same
So
answer.
the little formula is just to find the integral of the square root of 1 plus f prime squared. So if I've got y, I need the first derivative, x squared over 2.
Plus negative or minus 1/2 half to the x squared negative.
If I was gonna take the derivative, I would rewrite it as 1/2 x to the -1, and then -1 times a half is -1/2 x minus 1 minus 1 minus 2.
Squared.
You could do a quotient rule, but I'd be surprised if you wanted to do that. And then the next thing, oh, I hope I said that in my rules, yeah, square it. Y prime squared is x squared over 2 minus 1/2 x and -2 squared.
X to the. So we have.
You could leave it, because you're gonna type it into your calculator.
Oh, really?
It's up to you. If you want to clean it up, you're gonna have to FOIL it out. If you don't wanna clean it up, leave it. Just be careful how you type your exponents and such into your f-int part. And then our arc length is just gonna be the square root of 1 plus this derivative squared. And the limits of integration, they have to give you in the problem. So it's got to go from 1/2 to 2. You're going to want one of these on the test. These are nice. You don't have to do a whole lot of drawing or things. Yeah, you do have to be able to take a first derivative. You can do that? Yeah, and this one's one of the uglier ones. I mean, some of the rest of them are like y equals x squared. We should be good on those. So I'm gonna f int this if